motion graphs again. So formally, let's take these up. An object is in blank when it's this motion. When it's distance from a reference point is changing. Yes. Yeah. Alright. Speed is given. Speed in a given direction is called velocity. You guys learned this in science. The difference between speed and velocity is that velocity includes direction. Just like with our story, I needed direction. And then last one, something? Speed. Right, speed can be calculated if you know the distance and the time. So again with this, Kailash, remember this triangle? The famous science triangle?
Yes.
What's the order? Yeah, so DST. Okay, again for those who never seen this triangle, if you want to find out speed, the formula is distance divided by time. If you want to find time, it's distance divided by speed. If you want to find distance, it's speed times time. Whoa, yeah. So like a triangle that tells you 3 formulas. Alright. Keep this in mind. This you'll need to know it for grade. You'll need to know it for math and science. You'll use it a lot. Okay. Number 4. Which of the following graphs shows runner moving at the same speed? Jimmy. D. How do you know? Explain.
Because the slopes are the same.
Right. Slope is the same. Same slope, just like yesterday. Which means they are going at the same pace. Number 5. Which graph below shows that the runners start 10 yards further ahead than the other? Kenta? A. Right. Justification?
The y-intercept is 10.
Right. The y-intercept is 10 units higher. Okay, so you can see this one is at 0, this one is at 10. Okay. Number 6. Match the description below with the graph. Be sure to explain your answer. So, graph A, this one?
No. Oh wait, which one?
Yep.
Is description true because distance over time is the same at all points?
Right. So remember, this is a distance time graph. So a line going like this, it's not accelerating. It's actually going at a constant speed. Constant rate of change, constant slope, rate of change. Okay. Just like when we did equation of a line, the slope is the same throughout. Okay. B. Jimmy.
4.
4. So this one, the car is coming back. That's right. Okay, because it's moving towards home. All right. Well, for simplicity, we'll just say like the bottom is home. Your starting point. Basically. C. Graph C. Horizontal line. Yep.
The car is stopped because the distance is unchanging over time.
Right. All horizontal line. Horizontal line means stop. So remember that always, always, always. Okay, and then lastly, graph D. We have a graph like this. Joshua?
The graphs, number description 3 because it's like
Mm-hmm.
it's decreasing. It's going faster than it's
Okay, what can you say about the steepness?
it's
Like for this part right here, the steepness.
the steepness isn't like very much
Right. All right. So it's pretty flat, and so that tells you it's the speed is decreasing. All right. Especially because it's distance divided by time, so you can see that the distance that's covered is a lot less with the amount of time. So this one, steepness is steepness is less, steepness is decreasing, steepness is reduced. Steepness is
The rate of change is
less. Because this one is uses decreasing as well, so okay. In the second half. In the second half. Okay. Okay, use the following paragraph and graph to answer questions about 7 to 10. Write your answer in the blank below. Remember to include units and show your work. On Saturday, Ashley rode her bicycle to visit Maria. Okay, Maria's house is directly east of Ashley. The graph shows how far Ashley was from her house after each minute of her trip. So number 7, Ashley rode at a constant speed for the first 4 minutes of her trip. What was her speed? So first 4 minutes from here to here. How do I calculate her speed? Kenta?
200 meters per minute.
Okay, how did you calculate it?
You take the first value of x and the first value of y.
Okay. Or? Okay, Armin?
You divide distance by time.
Distance divided by time. Okay, or so what's your distance here? What was the distance covered in the first 4 minutes? 800 meters. And then how long? 4 minutes. Okay, so when you divide it, Kenta, what did you say your final answer was? 200 per minute. Meters per minute. That's right. All right. AKA, I just did rise over run. All right. So again, the slope of your line is the same as the speed in a distance time graph. Okay. What was our average speed for the entire trip? All right, for the entire trip. So right here, what was the distance covered? Armin?
1,600 meters.
1,600. And how long did it take for her entire trip?
10 minutes.
10 minutes. So what's her average?
160 meters a minute.
160 meters per minute. Remember, rate of change has units. So make sure, especially in a word problem, you always have the units. What was her average velocity for the entire trip? Okay, so remember what's the difference between velocity and speed again? Jimmy?
Velocity includes the direction.
Direction. Okay, so how would you write your answer for number 9?
160 meters a minute to the east.
Yes. Okay, so this one actually tells you northeast, southwest. You could say 160 meters per minute east like this, or you can say away from home. Like if it doesn't tell you northeast, southwest, you can say away from home. That would be direction. All right. Ashley stopped to talk with another friend during her trip. How far was she from her house when she stopped? Jimmy. 800 meters. 800 meters away from home. How long did she talk for? Ryan?
4 minutes.
For 4 minutes. For 4 minutes. All right. If I call this A, B, and see if I call these three sections, which part was she running the fastest? Yeah. See, how did you know?
Because she traveled 800 meters in 2 minutes.
Right. Okay, it's actually a lot faster, like double the speed, and you could either calculate it like that and justify your answer that way, or you can also say because the steepness of the line is more steep, which shows that it's moving faster. Okay. Alright, so that's good. Oh, this one I want to go over. Number 11. This one is tricky. Graph E. Graph E, this one is what? Jimmy?
Number 7.
The car is accelerating. Okay. Wasn't it? Didn't we have the same question right here? Didn't we have the same question over here in number 6? And we said that it was a constant rate of change. It's the same graph. Why is this one number 7 instead? Alicia? Yeah. If you take a look at the titles right here, this is a speed time graph, not distance time graph. 90% of the time, the graph that you'll see will be distance time graph. Alright, but in case EQAO tries to trick you guys and put a speed time, make sure you do take a look at the axis titles. And so this one, since it's speed and time graph, your speed is increasing. So it's 7. Speed is increasing. Okay. F. This one then, it will mean Jimmy?
Number 8.
The car is slowing down. Yeah. So when it's all the way to the bottom right here, oh actually that's the H. Okay. So in this case, speed is decreasing. Alright, again, this is because it's a speed time graph, not a distance time graph. This one. Kenta? 6, yeah. Constant speed. The speed is keeping at 60 kilometers per hour throughout. Right, so constant speed. And then, so the last one right here, the line is on the bottom. This will mean the speed. What's the speed right here? 0, right? So throughout the time, the speed is 0. And so that means the car is stopped. Speed is 0. Okay. Let's see. Which runner won the race? This is tricky. Okay, so let's have a vote. Albert, Bob, and Charlie. Who said Albert won? Who said Bob won? Who said Charlie won? Okay, good job. Yes, Albert did win. How did you know? I thought Charlie did because it was the furthest. No? Why is it Albert?
Because in a race, you want to get the least amount of time and the distance.
Right. Albert finished the race in 12 minutes. Oh. That's a big difference. 12 minutes and 12 seconds. So, what is this, meters? So, if Albert took 12 minutes to run 100 meters, maybe, I think they're snails or worms. Okay. Which runner stopped for a rest? How long was the stop for? So who was unfit here? Chaya?
Case, I mean Charlie, this is stop for 5 seconds.
I keep thinking it's minutes. Yes, so for 5 seconds. From 8 to 13, that's 5 seconds right there. Okay, and notice I'm only counting from here to here. So don't just say, okay, this is 13, and so it's 13 seconds. Okay, so remember segments. How long did Bob take to complete the whole race? Jimmy?
14 seconds.
14 seconds. Okay, from the start to the finish. Right here, this point, it's at 14. Explain your answer. How do I explain it? He ran 100 meter in 14 seconds. Okay, and then calculate Albert's average speed. So again, what's the formula for speed?
Distance over time is equal to 100 meters over 12 seconds, which is 8.3 repeated meters per second.
8.3 meter per second. Good. Okay, again, rate of change, you have to have units. And in this case, in most cases, you have 2 units, meters per seconds, just like unit rate. Okay. Okay, so we have about 10 minutes left. Can you guys take 5 minutes to finish up the rest? And then I do want to take it up with you guys before you go. Okay, so take 5 minutes, finish these, and then we'll take it up. Come on. Yashika, what do you get for the first answer? Accelerating. Okay. Maya. Sorry? Constant speed. Remember, this is a speed time graph. So this is increasing in speed, and then this C's at 10 meters per second. Okay. And then, Nicole? Right. Decelerating. So the speed is reducing, and then eventually it comes to Emily at rest, which means AKA stop. Okay, and then probably a red light, and then after the red light, what happened? Richard? Accelerate again. Okay. Looking at this graph, which segment looks like it was going the fastest? Armin?
OA.
Oh, actually, okay, let me rephrase my question. Which segment was accelerating the fastest? Then, yeah, OA. Yeah. And which part did they stop the longest? Jimmy? Stop the longest?
That's the only time they stopped.
Oh yeah, right, that's the only time they stop. Okay, so I tricked myself too. Yeah, this is the only time they stop. I was looking at these ones right here, but yeah. This is the only stop. This is not a stop, remember. It's a speed time graph. Alright. On the back right, oops, sorry. Grant, at what time did he start his journey? What time did he start? Grant? With the headphones? Yeah. Okay, what time did Pete start his journey? 1:30, right here, between 1 and 2, so that's actually 1:30 p.m. Ensign?
10 kilometers.
10 kilometers, right here. Samantha, how long did he rest for? 30 minutes. Again, this is a distance time graph, so how you read it is different. And then, what was the total distance traveled? Cypher?
Total distance traveled. Excuse me, I can't quite see it on the screen. My eyesight is bad.
You have it on your paper too.
Forgive me, I don't have my paper out right now.
All right.
May I get closer to the screen?
Oh yeah, definitely. Total distance traveled.
The total distance
So this part is 10.
Yes, that's 18 plus 2. Wait, times 2, which is 36, I believe.
Right.
36 kilometers.
Perfect.
Kilograms.
All right. Yes. So remember these ones. It just means you stop. It doesn't mean that you don't calculate that 10 or anything. You just stop. You're still away from home. So in total distance is 36. Okay. Last one. Luke. Temperature stayed the same for time and then false. Which letter is it? Stays the same and then false. D, right. Stays the same. And then what type of graph are these? Yeah.
Temperature, time.
Temperature versus time graph. So again, reading the title carefully. So the first one is D. Steven, next one.
Second one is C.
C, right. Raises and then falls quickly. Is that possible?
Yes.
I don't know.
And then temperature control the area.
I don't think so. Okay, so can't drop this dramatically. Okay. The next one, Shraya.
Hold on.
All right, next. Jimmy. The temperature is always the same. Sorry?
A.
8. Wait, sorry, I didn't hear you. All right. Grant. Sorry, not Grant. Ethan. My bad. Grant, you answered already.
Temperature is always the same.
No, the temperature rises, stays the same, and then falls.
F.
F. All right, and then the last one, Alex.
E.
E. Good. So you were paying attention. Okay. So, that's today's lesson. No homework. Just remember these are called motion graphs. Motion graphs, you have to look at the titles of the axis. A change in just one word could change all your answers and make it all wrong. So you have to be careful with that. Okay. So no homework. Yay.